Right, our discussion remains critically important on trigonometry, but we begin by looking at trigonometric ratios, as we know that there are three important trigonometric ratios in the curriculum. Right, sine is one of them. What is the other trigonometric ratio that you can remember? If it's not sine, then what is the next trigonometric ratio?
There is cos
Yes,
and
there's
tangent.
cosine, and there is tangent, T. Okay, tangent. Okay, right. So we have the following. We have what we call the sine. Okay, this is not sin because there's an E, so it's sine. Some people make a mistake and claim it is sin, like a biblical sin for a wrongdoing, but it is not. Okay, and then there's another one called cosine. What is the difference between sine and cosine? Well, it's because cosine has co before the sine. So it's cosine. And then now there's another one we call the tangent. Right, so we remember that these functions are written as follows. This one is normally written as the sine of theta. This one is written as cosine theta. This one is written as the tangent of theta. Okay, so these are the three basic trigonometric ratios. But in mathematics in general, you will learn that you can take the reciprocal of the sine and it becomes something we call the cosecant. Like that. If you take the reciprocal of the cosine, you get the secant of theta. If you take the reciprocal of the tangent, it becomes the cotangent of theta. Okay, so they are basic, they are six, therefore, but now in the current curriculum, it is popular that we emphasize the three in the schools. Okay, so yeah, we note these here. Okay. If the sine of x is minus 5 over 13 and the angle theta lies between 90 degrees and 270, we must be able to calculate the tangent squared times the cosine squared without using a calculator or a computer. So something to note here. First things first, you need to draw a diagram. So to draw a diagram, you need to note that you have been given the sine of x, which is minus 5 out of 13, but it's not the only piece of information the examiner gave, but they also gave this information here. Right. Now, what do we do with this? We need to draw a diagram. How do we draw the diagram? Okay, in drawing the diagram, we draw a vertical line and we draw a horizontal line. And we need to recall the 90 degrees, 0, 90, 180 degrees, 270 degrees, but also remember the 360 degrees. So note these things. Now, we have the following. Okay. At this point, what more do we then need to realize? Okay, we need to remember the cast. The cast rule. Cos, the C stands for cosine, the sine, and then the tangent. So there are a couple of things you need to remember here. Okay, so cosine theta, and this is the sine of theta, and this is the tangent of theta. Okay. We need to look for the quadrant in which the sign is negative. In which quadrant is it negative? So the A stands for all positive. All trig functions are positive. all trigonometric functions are positive in this quadrant. But also, I want us to note the fact that this one is the first quadrant, this one is the second quadrant, the third, and this one is the fourth quadrant. Okay, now, the quadrant means obviously is a part of the four divisions of the Cartesian plane. Right, so now let us continue here and see what we get. Okay. Now, we need to draw this a small triangle in the right quadrant where the sign is negative. So the sign is negative in the third and the fourth quadrants because here the sign is positive, but here in the first, all trigonometric functions are positive, and therefore we must draw in the in any of these quadrants. But it must be a quadrant in which x lies between x is bigger than 90 degrees, but is smaller than 270. So, in other words, bigger than 90 degrees, because here you're moving from 90 to 180. So you are in the second quadrant. More than 90 degrees, you are in the second quadrant. But also less than 270. 270 is this one less than. So you're somewhere here. You are between 270 and 180. So you are somewhere there. And that puts you in the third quadrant. So the quadrant in which the sign is negative is therefore the third one. Okay, good. And we're excited about this. And we're going to just do a small decoration. And we're going to do a construction. Okay, so we construct here a triangle, like so. We construct here a triangle like so. And this triangle is right-angled. Okay, it's a right-angled triangle. And we note a couple of things that we need to draw here. The angle there, x. All angles are measured from the positive real axis, from the 0-degree line, 0-degree ray. Okay, good. We're excited about this, but we have a couple of things to realize that we must remember that we use SOR, ka, so meaning, right, the sign is opposite of hypotenuse, and if you have x here, you have the opposite, and the opposite is opposite the x is 5. Can put 5 here, or minus, good. Right, okay. And it's opposite of hypotenuse. The hypotenuse is this one, which is 13. Okay, we're excited, and this is good news for us. Okay, now a couple of things then remain critically important, but it is to look at these and reason together. Okay, so what else do we know? We need to know that we can get one of these. We can get the adjacent side because we have two sides here. So this is like our R in terms of the convention we use. The vertical one is like is parallel to the y-axis, and therefore it is y equals. And this horizontal one here is actually our x. Okay, it's x, but it's different from the angle x. Please, okay, it's the side of this triangle here, and I can see the role of x appearing in two places, but yeah, it must be treated with utmost caution. Okay, so the examiners do this sometimes. They let the variables play around. Okay, let us actually continue with these particular problems and analyze these together. Okay, we proceed as follows. Right, so we remember there is what we call Pythagoras theorem. We must get this side here. So to get this side, we use Pythagoras theorem. Pythagoras says x squared plus y squared. X squared plus y squared is r squared. Okay, we plug in the y, which is -5. We plug in the r, which is 13. So we therefore have x squared plus, what is the y? Is -5. We square that. The r is 13. Similarly, we square this. Our objective is to find x, and therefore 13 squared is 169 minus 25 from the -5 squared. Okay, so what do we obtain out of these? So we have, therefore, that x squared is 169 minus 25. What is 169 minus 25? What do you think, Tando? All right, it's 144. And therefore, if we want to get the answer to this, we proceed as follows. We then say that this is 144. We apply the square root and we put a plus or minus. We also apply the square root here so that we have x squared equals, in particular, we have only just x because the square root removes the square, okay, from the x, and therefore we have the square root of 144, which is only 12. Okay, so x is plus or minus 12. So we have therefore that x is 12. But it is the negative 1 because it is negative 12 because it is on the left side of the origin. And now it means we conclude we must choose only one result. So we choose only minus 12. Why only minus 12? Because we are dealing with the left arm of the x-axis. Okay, good. Now we are excited about this. This diagram, also called the Argand diagram, has been drawn. Argand diagram. Right. This diagram, also called the Argand diagram, has been drawn for us. Okay, good. So we are excited about this, and we proceed. Okay, the Cartesian plane. Cartesian plane is also another name of this particular diagram. Right, so two-dimensional plane, we have that. Okay, good. It's called the two-dimensional plane because we have actually the x-axis and the y-axis, and therefore it has two dimensions. Okay, the x dimension and the y dimension. Okay, right now, what else do we need to have here? Okay, good. We are excited right now, so we have our wonderful triangle here. Now, with this information, the examiner, we need to remember what we need to get. We have 10 squared x times cosine squared x. But we remember our old friend, the mnemonic technique to remember. So we have the tangent. So the tangent is opposite of adjacent. Opposite of adjacent. Tower. Opposite of adjacent, we go back to the diagram. And we then say, okay, if we're dealing with the opposite the angle is -5, the adjacent is -12. Opposite, okay, this is the opposite side because this is like the angle x here. So the opposite side is -5. The adjacent is the other side, which is -12. So if you say opposite of adjacent, we have, from the tower, opposite of adjacent, which is -5 over -12. Good. Right, so we have -5 out of -12. What do we do with this? We put a big square, like the square on the tangent. And therefore now we have also the cosine square of x. What is the cosine? Right, the cosine of x is this one, and we're dealing with the adjacent of hypotenuse. Adjacent is -12, hypotenuse is 13. Adjacent is -12, hypotenuse is 13. Right, so adjacent is -12, hypotenuse, because adjacent of hypotenuse is 13, and this is squared. Okay. Right, we are in business. And if we square this, okay, the negative cancels the negative. And if you square 5, you get a 25. You square 12, you get a 144. You square -12, you get a plus 144. Divided by 13 squared is 169. Now we have 144 divides 144, giving us a 25 out of 169. Okay, so the 25 is 5 squared. This is 13 squared. These are relatively prime to each other, and there is no other divisor that can help us simplify this, and we are done. So just note that tando. So these remain extremely important. Now, the certain things that I want us to remember. Let us look at some identities that must be remembered. So trigonometric identities. Right, looking at the trigonometric identities. What are the trigonometric identities of choice? There's something we call the quotient identity. Right, quotient identity. And there's something that we call the squares identity. Right, squares identity. Okay, these things will be available, will be availed to you. The video will be posted to you. Okay, right. So, what is the quotient identity? The quotient identity, we shall look at the proof of this, but the tangent of theta is the sine of theta divided by cosine theta. Tangent of theta is sine theta over cosine theta. The squares identity is the fact that if you have the sine squared of theta plus cosine squared theta, the result is always 1. Sine squared plus cosine squared theta, always 1. Take note of that. These remain extremely important. And we shall look at lots of identities for us to play with, so stay tuned. Okay. And this here will actually prove very, very profitable. So we are very thrilled to deal with this. Okay, here are some problems that we can solve. Let's look at these questions. Right, we need to learn how to simplify. Right, simplify number 1. Sine x, tan x, cosine x. Number 2, tan x times sine squared of x plus tan x times cosine squared of x. Let's look at the solutions to this. Right, we proceed to look at the solutions to this. What are the solutions to this? Sorry, if we have, for example, sine x times tan x times cosine x, how do we simplify these? So we proceed to simplify these. Number 1, the examiner decided to give us the trigonometric sine of x times the tangent of x times cosine x, which is, what is this? This is sine x. What is the tangent of x? We know the quotient identity. What is the quotient identity? Right, so the quotient identity tells us something important, that the tangent is the sine over the cosine of theta. Okay, so we have that. So this is the sine of x over cosine x times cosine x. So this one cancels. And then we have sine times sine, and sine times sine becomes sine squared of x. Okay, so this is the answer, and there's no further simplification that is possible for this. So we leave it at this point. Just something to note for us. Okay, but number 2 is just very straightforward, but very important. Number 2, I'm giving it to you, so please pay specific attention and give it all your strength. Give it all your strength. Now, tangent of x times sine squared plus the tangent of x multiplied by cosine squared x. What is the answer to this? Right. What do you think? What should we do here to simplify these, Tando? What do you think? What do you think, Tando? Too difficult. Right, the tangent of x is a common factor. Is the highest common factor, so that now you have the tangent of x that appears in 2 places. It appears here, but it also appears there. So you pull out the tangent of x, and if you do so, you're going to be left with whatever appears. Right, so you're left with the sine squared of x plus cosine squared of x. And then now at this point, you have the following. What is sine squared plus cosine squared? The result is a 1. And therefore, tangent of x by 1 is the tangent of x, and that is the result. That is the result. So we're good. Okay, let's look at the next problem. Number 3. Right, you need to simplify this if you're given the following. If you're given sine squared x multiplied by cosine x plus cosine cubed of x, you divide these by cosine x. And at this point, what are you supposed to do? You're supposed to simplify this. You need to simplify this. And let us see how to simplify this. Let us see how to simplify this. How do we simplify this? So look at the solution to this. Right, we look at the solution to this. So now, if we have to simplify these, I'm giving it to you. Guys, anyone, what do we do here to simplify these here? So we are given the sine squared x times cosine x plus cosine cubed of x, and this is divided by cosine x equals. What do we do here, and how do we simplify these? What do we do here, and how do we simplify these? Anyone, please, quickly? Okay, by merely looking at these, there's something one can see, but you can see that there is cosine in 2 places, so you can see the appearance of the cosine here, and the cosine as well appears here. So with that, then it means that we can factor out cosine x. So cosine x, a common factor, if you factor out cosine x, you are left with the trigonometric sine squared of x plus, okay? If you factor out cosine, there's cosine cubed. Okay, if you have the cosine cubed, then you factor out one factor of cosine, so you're going to be left with cosine squared of x. You divide the whole thing by cosine x. Okay, divide these things, and you have sine squared plus cosine squared. What is sine squared plus cosine squared? Okay, sine squared plus cosine squared is a 1. Right, so, and that is the answer. So this whole giant expression is equivalent to 1, and we've simplified it. We have simplified it. Any question? So, any question? Okay. Okay. Let's look at the next question, guys. Number 4. Okay, even yeah, you might not have enough time to always copy, but the video is gonna be available. Okay, so you're gonna watch the video. So you're gonna have the video, and when you have the video, then you can copy everything. Let's look at this one. What about if you have, we give you sine x plus cosine x. You divide everything by sine squared x minus cosine squared x. And we have a square there, like so. Okay, good. Now we have this, but what then we do here? Right, this is an exercise, so we need to simplify these. How do we simplify these? How do we simplify this? How do we simplify these? Anyone?
I think we expand the bracket.
Yes, we expand the numerator. Right, and so we present a solution to this. Right, so in presenting a solution to this, we expand the numerator by opening up the brackets or the parentheses. So we have sine x plus cosine x squared. You divide everything by sine squared x minus cosine squared x. Okay, if we expand this because it's being squared, we write the following. So we're going to have sine squared. We're going to have sine squared x. So we just square the sine, and the next thing is to multiply sine x by cosine x by 2. We multiply sine x by cosine x by 2, getting 2 sine x by cosine x plus cosine squared x. We divide by sine squared x minus cosine squared x. Okay. What do we do next here? Anyone? What do we do next at this point? Anyone, please? Your input. Okay, so we have the sine squared x plus twice sine x times cosine x plus cosine squared x. We divide by sine squared x minus cosine squared x. Okay. I was asking the question, what do we do here? Tando and Yolanda, anyone?
We should factorize.
We can view factorization. Okay. We can group like terms. Sine squared plus cosine squared. We group sine squared and cosine squared. Then we have 2 sine x times cosine x. We divide by sine squared minus cosine squared. What is sine squared plus cosine squared? What is it equal to? Anyone?
1.
1. Well done. That is the square's identity, Pythagorean identity. So this is a 1 divided by or added first to 2 sine x times cosine x, and we divide everything by the sine squared minus cosine squared. Okay, and therefore, what do we know about this? For example, right, and what do we know about any of these here? What do we know about any of this? So we have in the denominator sine squared x minus cosine squared x. What is sine squared x minus cosine squared x? Okay, the difference of 2 squares. So which is exactly sine x minus cosine x, sine x plus cosine x, which is what the examiner wanted. So one thing that we can realize is what the examiner wanted here. So I would like us to make a modification here and realize that this numerator here can be written still as sine x cosine x squared. So we can leave it this way so that we still have here sine x plus cosine x squared. Okay, now with this in mind, I would like us to transform this numerator and keep it as it was, okay, in terms of the square. Right, it can be expanded, but we can keep it into with its square to just make sure that we are brief. So we have here with us sine x plus cosine x squared. Sine x plus cosine x squared. Okay, so obviously if you look at these and you divide, right, so the sine x plus cosine x cancels one of the factors here, and we are able to get. So at this point, I would just say it's best to leave this. You can open up the brackets, yes, but we have seen the factorization that it actually simplifies things with ease to just keep the top like that, keep the bottom this way, and when you get to this point, you still have that, and you can reduce some of the steps here, like you can cut out this step just to make sure the solution is very nice and short of this. And obviously you can see that you can cut out a couple of the steps, like this step, you can actually cut it out. So that now, how many steps will that be? So this is the step we had. So in particular, maybe we can shorten these as follows, okay, because this is already the answer. But I would just think that, let me just write a very brief solution to this and say that the top, you can open up the brackets, yes, but you can write it with the parentheses like this. And you then can just factorize the bottom, sine x minus cosine x into sine x plus cosine x. Right, and upon this, like you saw on the previous page, so what you have is that this cancels one of the factors, so that you have sine x plus cosine x over. So in other words, sine x plus cosine x is going to cancel one of the two factors, giving us sine x plus cosine x in the numerator, and that is going to become exactly sine x plus cosine x divided by sine x minus cosine x. Okay, and I found that I think that this is a much smarter solution. And so you can just be in a position to have fewer steps that are very important for us to consider. Okay, so yeah. Okay, so you have this. So you cancel them out, and then you have this. Okay, so what is the answer? And this obviously remains as the answer to question. There are many ways to write these, but yeah, okay. So we started with this. Square it here. Now you have the square there, keep it as it is. Difference of two squares here, so you can factorize the denominator and write sine x minus cosine x into sine x plus cosine x. So you can see the sine x plus cosine x cancels one of the factors in the numerator, leaving us with the sine x plus cosine x in the numerator and with sine x minus cosine x in the denominator. This here is the answer to the question. You can just leave it like that. Okay, let's look at the next question, please. Right, so we must also learn to complete. Let's just complete a couple of things. Right, let us complete. Right, if you need to complete 1 minus sine squared x is equal to what? Okay, and then now the next one is you need to simplify. One minus sine squared theta or x divided by cosine x Yeah, let's see what we can do here. Let's see what we can do here. Okay, Tando, let's complete this. 1 minus sine squared. Tando or Yolanda, what is 1 minus sine squared? What can we put here if they say complete? What do we put here? If the examiner is to say complete, what do we put here? What is 1 minus sine squared equal to? Anyone?
I think it's 1 plus sine x into 1 minus sine x.
Oh, yes. Okay, you're right. So you can factorize that. But what the examiner, so you're looking at difference of two squares. So you're right, you're right. I mean, it's correct. But now you need to remember that sine squared x plus cosine squared x is equal to what? It's equal to 1. So you can transpose the sine so that cosine squared is 1 minus sine squared. So wherever you see 1 minus sine squared, because you transpose the 1 minus sine squared. So 1 minus sine squared is what? Is cosine squared. What is 1 minus sine squared? Cosine squared. Divided by cosine x. What is cosine x now? Cosine squared x divided by cosine x. Okay, not to simplify. We're trying to simplify here. So cosine squared x divided by cosine x is just cosine x. So these are the answers. So whenever you see 1 minus sine squared, it is equal to cosine squared because of this identity. And this is also called the Pythagorean identity. Pythagorean identity. Okay, let's complete this one. Complete. One minus cosine squared x is equal to what? Can you fill in? Anyone? Anyone? Anyone?
I think it's sine squared x.
It is sine squared x. It is sine squared x because we work it out from sine squared x plus cosine squared x equals 1. So you can transpose the cosine squared so that sine squared x is 1 minus cosine squared. Okay, what is 1 minus cosine squared? It's sine squared. Okay, so yeah. All right. Let's look at this one. Here you need to prove. Right, you need to prove that. It's sine x times cosine x. Divided by 1 plus minus sine squared. Which is 1/2 10x. You need to prove this. So how do we prove this? How? Anyone? So we present the proof. Here I'm gonna let the left-hand side. Take the left, because you take the most complicated side and simplify it. So you're gonna take the left-hand side because it's more complex, it has more terms. So we have sine x times cosine x, and you divide everything by 1 plus cosine squared minus sine squared. Okay. What do we do here, anyone? How to simplify this? How do you simplify? Okay, it's very straightforward because in the numerator you have sine, cosine. In the denominator, you can just group the terms. So this is cosine squared, then you put 1 minus sine squared. What is 1 minus sine squared? We completed before. 1 minus sine squared is cosine squared. So this is cosine squared. The 1 minus sine squared is cosine squared, and you have sine x times cosine x. So what you're having therefore is that the left-hand side is sine x cosine x divided by, okay, sine x times cosine x divided by, okay, here you're going to have this one. It's a plus. So this is cosine squared. We have 1 minus sine squared is cosine squared. So cosine squared x plus cosine squared x is 2. Cosine squared x. So the left-hand side is, okay, cosine divides. So you have cosine squared, then cosine is going to remove 1 from the square, and therefore you have sine x divided by 2 cosine x. So sine over cosine is what? There's 1/2 and 1/2 from the 2 in the denominator. And you have cosine x. And this is the tangent of x, which is the right-hand side. Which is the right-hand side. Okay, so this is what we get. So in other words, hence, if ever you see, if you happen to see sine x times cosine x and you divide it by 1 plus cosine squared minus sine squared. This is 1/2 10x. 1/2 10x. So we've proven that the left-hand side is equal to the right-hand side. Okay, now let's look at the next question. Let's look more at reduction formulae. Right, reduction formulae. Let's look more at reduction formulae and see what we can get. Now, the reduction formulae themselves remain critically important to us, and let's see what we can do to master problems that involve reduction formulae. The questions will normally say simplify. The questions will ordinarily say simplify. What are we simplifying? What are we attempting to simplify here? Right, here's the question we need to simplify. So we need to simplify the sine of 180 degrees plus theta multiplied by the sine of 360 degrees minus theta minus cosine of 180 degrees minus theta times the cosine of minus theta. So how do we simplify these? Anyone? So we'll look at the solution to this. So to simplify this, we proceed by looking at the sine of 180 degrees plus theta times the sine of 360 degrees minus theta minus the cosine of 180 degrees minus theta into the cosine of minus theta. Okay, now a couple of things are very important is to look at the cast diagram. Right, this is the cast diagram, and '90, 180 degrees, 270, 360 degrees. So now at this point, what we have is, so this one is going to be 90 degrees plus theta, 90 degrees minus theta. 180 degrees plus theta, 180 degrees minus theta. 360, this one is going to be 360 degrees minus theta. Okay, so this is going to be 360 minus theta. Just write it clearly here. (360 degrees minus theta). But also, we need to remember a couple of things and know our knowledge of the fact that this one is the first quadrant, the second, the third, and the fourth quadrant. So that's something that's extremely important to note. Okay, so just note that. Right, with that said, then we look and analyze this and get the answer. In which quadrant is 180 plus? 180 plus is in the third quadrant where 10, because according to the cast diagram, 10 is positive in the third quadrant, and therefore the sign, because we have sine of 180 plus, sign is negative. Okay, so we have 360 minus in the fourth quadrant where the sign is negative. 180 minus is in the second quadrant where the cosine is negative. Okay, this is theta. Okay, good. Let's continue. So what you have here is that we have minus sine theta into minus sine theta. Minus sine theta into minus sine theta. Then obviously now you have this, which is minus into minus cosine theta, cosine theta. Minus into minus cosine theta, cosine theta. What is negative by negative? It's positive. Sine by sine is sine squared theta plus, okay, negative by negative is plus cosine squared theta. What is sine squared theta plus cosine squared theta? Anyone?
It is 1.
It is 1. Well done. Right, and look at reduction formulae. Right, and look at reduction formulae. Okay, let's look at the cast diagram. Right, in view of the cast diagram, we know that this one is cosine theta. Tangent of theta, sine theta, all positive. 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. Okay, so we continue. So now what we have here, okay, so here we have 90 degrees minus theta. Okay, so if you have this, then now you want to go back to the first quadrant, because then you use 90 minus, but to move here, you have 90 degrees plus, but you also have 180 degrees minus. Okay, if you're here 180, you're moving towards 270 is 180 degrees plus to move towards 270. But if you're at 270, you want to go back, you reduce 270, and hence reduction formula, you subtract theta. Okay, good. Let's continue quickly. I want us to look at this diagram and make sense of it. But I'm going to engage you a lot here because I want us to look at the basics, because some of you might have not quite covered the basics in school yet. So let's just look at these, but let's look at these very carefully. So we have 360 degrees minus theta. Yeah, 270 degrees plus theta. Okay, you see, the thing is, if you're at 270, you want to move towards 360. Okay, these are like positive angles. So we're going to look at another cast diagram for the negative angles. Okay, so now looking at the positive angle, you're saying if you have 270, you want to move towards 360. So what you're going to do, you're going to say 270 plus theta to move towards 360. If you're at 360, you want to go back, you say 360 minus, and hence reduction formula. Okay, now let us play around a little bit more. This one is the first quadrant. This one is the second quadrant. This is the third quadrant. And that is the fourth quadrant. 1, 2, 3, 4. So let us play here a little bit together. So here you need to complete. So we're playing the game of completion. There, Tandor and Yolande, we are playing the game of completion. So we need to complete the things. Okay, so let's look at the first one. We can give you the sine of 180 degrees minus theta. What is the answer? Number 2, the cosine of 360 degrees minus theta. The tangent of 180 degrees minus theta. Number 4, the sine of 90 degrees minus theta. Right, so let's play here. The game here is the game of completion. I'm gonna get around lots of functions here. Right, so if you have 180 degrees minus, in which quadrant is 180 degrees minus? 180 degrees minus is in the second quadrant, because when you're at 180 degrees here and you want to go back to 90, you must minus from 180. So 180 minus something takes you back to the second quadrant. So that in the second quadrant, the sign is the only one that is positive. So that obviously the result here is going to be positive, the sine of theta. It's going to be positive, the sine of theta. The next one, what is the cosine of 360 minus theta? Tando? Okay, let's do it together. Okay, now to find the answer to 360 minus theta, what you need to do is to look at, you need to memorize this cast diagram, because if you're at 360 degrees, at the 360 degree ray, you're here, and now you want to go back to 270, you say 360 minus theta, and that puts you back in quadrant 4, and these are quadrants. Quadrants. Okay, so now at this point, If you touch to the fourth quadrant, this is the minus is in the fourth quadrant, and the cosine is the only one that is positive there. So the answer is just going to be positive cosine. So you just copy cosine and the theta. Let's look at 180 minus theta, and when in which quadrant is that one? It is in the second quadrant. So in the second quadrant, the sign is the only one that is positive, and therefore, if you have 180 minus, it is the second quadrant that you are dealing with, and therefore, the tangent that appears here is going to be negative. So you write negative like this, and you copy tan and theta, so you have the tangent of theta. Anyone? What is the sign of, okay, this one you can't get yet. Okay, if you're looking at the sign of 90 degrees minus theta, it's in the first quadrant. 90 degrees minus theta is in the first quadrant where all the functions are positive, so the answer is going to be positive. But at 90 degrees and 270, you apply cofunctions, and there's something we call the Coco rule. Something called the Coco rule. Coco rule means that if there's no co, you put on a co. Okay, the sign, you put on a co on the sign, and putting on a co on the sign, it becomes cosine theta. Cosine theta. So sine changes to cosine at 90 degrees and 270. Okay, let us practice a little bit more. Now we're going to do changes here. Okay, let's do something here. Like, let me put cosine here. So I'm also going to change the results here. Okay, now if I give you cosine here, and I put 10 here, and we put 10 here, and you put cosine here. Okay, yeah, this one, the first one. Okay, what is cosine of 180 degrees minus theta? Anyone? Tando, Yolande, anyone?
It's gonna
Negative
be
cosine theta.
Please come again. Yolande alone, maybe, I don't know. Okay, because speaking at the same time. So yeah. Okay, Yolande first.
Negative cosine theta.
Well done. Okay, that's correct. Negative cosine theta, because you need to look at the fact that 180 minus is in quadrant 2. There's 180 minus in quadrant 2, and therefore, but the sign is the only one that is positive, so the cosine is going to be negative. Cosine is going to be negative, and then you copy cosine and the theta. Like this. Okay, anyone? The second one? The second one is the tangent of 360 degrees minus theta. Either Tando or Yolande, anyone? But yeah, Tando would be the ideal candidate because I know that they tried to give me the answer at the same time with Yolande, and now I could really get whose answer was the most correct, etc. So yeah. Okay. Now, number 2, anyone, please?
It's going to be negative 10 theta.
Well done. Okay, well done. Because 360 minus is in the fourth quadrant, and 360 minus theta is in the fourth quadrant, and the cosine is the only one that is positive there. So the tan is negative. Tangent is negative, and you copy tangent and the theta. Okay, this one here. Number 3, anyone?
Negative 10 theta.
Well done, Yolande. Negative 10 theta. Okay, it's negative 10 theta because 180 minus is in the second quadrant, and the sign is the only one that's positive there, so the tangent is negative there. Tangent is negative, so you write a negative and you copy tangent and the theta. What about cosine of 180 degree of cosine of what? Of 90 minus theta? Cosine of 90 minus theta, anyone? What's the answer?
It's going to be cos theta.
Mm-hmm. Okay, that's fine, Tando. What do you think, Yolande? Tando said cosine theta. Tando said cosine theta. What does Yolande think?
Maybe sine theta.
All right. I'm happy that you guys are good stars. Okay, now I want to mention something before I write the answer here. Okay, here, if you are at 360 degrees and you want to go higher, so you can increase 360 degrees by adding theta to 360. So 360 plus is also in quadrant 1. So now 90 degrees minus theta is in quadrant 1, where all functions are positive, all positive at 90 minus theta. So the answer is going to be positive. But when we, as I said already, the COCO rule applies at 90 degrees and 270. So which means, therefore, at this point, what you're going to have is the following. COCO rule. If there's a co, you remove the co. So you have cosine. And you remove the co, and you're left with what? Sine. So it becomes only sine theta. So in other words, at 90 degrees, if there's a co, you remove the co. If there's no co, you put on the co. Let us play around with more problems here. Let's do more of this. Okay, this time around, I'm going to erase. I'm going to clean up. And I'm going to clean up. Okay, so I'm going to clean up. Okay, so now at this point, if we have the following. So we're going to have lots of 90s and 270s. Okay, let's just put a 270 as well. So if you put a 270 degrees here and you put cosine. Okay, so we're going to put a cosine here. And 180 degrees minus, you're going to put something else. Right, at 180 degrees minus, what can you put? Okay, so let's put the cosine again. Okay, I'm gonna change this one. Right, so, okay, I'm gonna change this one and put 360. Right, so if I have 360 minus, then I can put cosine. Let's put sine. And then here, we're gonna change this one at 180 degrees minus. You can put another cosine here. And at 90 degrees, we can put, let's make this one 90 degrees plus, and we put cosine. Okay, now let's look at anyone, the first one, 360 minus theta, sine. What's the answer?
Negative sine theta.
Okay, well done, because 360 degrees minus theta, 360 degrees minus theta is in the fourth quadrant. Then the fourth quadrant, only cosine is positive, and therefore the sine is negative. So the sine, the result is going to be negative. Negative, and therefore you have the sine of theta. Okay, now let's look at number 2, for example. Cosine of 270 degrees minus theta. What's the answer, Tando? I've heard answers from Yolande, but yeah, Tando. I need to give Tando a chance. It's not fair to have Yolande alone. Okay, I know that there's another student called Tenulo. I'm sure that Tenulo has joined us, or I'm gonna have Tenulo as well from time to time participating. Okay, we're doing this one now. If somebody's wondering, I've written so many things on the screen. Right, we're doing this one. We're doing number 2. Cosine of 270 degrees minus theta is equal to what? This is the question you're asking. It's equal to what? Number 2. I know that we have not seen these quite yet turned out, but what do you think?
It's gonna be negative cos theta.
Okay, good. That's fine. Let's analyze it together. Okay, now we're dealing with 270 minus. In each quadrant first, you must first identify the quadrant that you're dealing with, or the quadrant you are in. So 270 degrees minus theta is in quadrant 3. Okay. And which functions are positive in quadrant 3? It's only tan. So which means, therefore, the cosine is going to be negative there. Cosine is going to be negative there, so it's going to be negative. Therefore, but at 270 degrees and 90 degrees, their function changes, co-function changes, the Coco rule applies. So Coco rule is going to come and say cosine has a co, cosine has a co. You remove the co, and you're left with the sine. So the answer becomes negative the sine of theta. Right, so the next one is number 3. Senulo, what do you think? Number 3, cosine of 180 degrees minus theta. Senulo, what do you think?
I think it's gonna be negative cos theta.
Okay, that's an interesting point. Okay, I'm having parallel as well. Right, so now if you're dealing with 180 degrees minus theta, so 180 degrees minus theta is in the second quadrant where only the sine is positive and therefore the cosine is negative, and you just copy cosine and theta. So it's negative cosine theta. Okay, now let's look at this one here. 90 degrees plus theta in each quadrant is it? 90 degrees plus theta in each quadrant is it?
The first quadrant.
Okay, let's check. 90 degrees plus
The
theta.
second.
It is the second quadrant. Well done. 90 degrees plus theta is in the second quadrant. So if 90 degrees plus theta is in the second quadrant, then what functions are positive in the second quadrant? It's only sine theta. It's only sine theta. So cosine is going to be what? Negative. But there's a co-function change. There's a co-function change. So we're doing co-function changes at 90 degrees plus in the second quadrant. There's a co-function change. So if you have cosine, you remove the co by the Coco rule. You remove the co and you're left with the sine, and that becomes the sine of theta. Okay. We're doing more reduction formulae, so stay tuned because we're going to be playing the game. So this is an exciting board game, but it's a game of the reduction formulae in trigonometry, bringing together learners, but also allowing us to explore this a little bit more. Okay, we are mastering trigonometry from beginning to end. Right, but now I'm gonna make changes. Okay, this is recorded, guys, so don't worry if you do not copy something. When I have a chance to watch this video again, you can pause the video and copy your notes. Okay, obviously these notes must be copied down to make sure that you follow exactly what is happening. So yeah, I'm just making sure that we play more today. Right. Now let's deal with this one here. Here you can have 90 degrees minus theta. And let's put 90 degrees plus theta. And put let's make it 270. Right. Let's make it 270 degrees minus theta. Okay, make it minus here. And then you put, okay, I'm just formulating these questions for us to practice. We have this. And then now the second one here is going to be like 360 degrees minus, it's okay. And then we can put 10. And then now here you have 90 degrees plus. And you put the cosine, it's okay. And then now this one is going to be 180 degrees plus. And we can put the big sign. Okay, let's just do this. Right, number one. Anyone? If you're dealing with cosine of 270 degrees minus theta, what is it going to be? What is the answer?
Negative cos theta.
Okay, negative cosine theta. Is that your Lande?
Yes.
Okay, that's awesome. That's fine. Okay, why do you think the answer is negative cosine theta, Yolande?
Because cos is positive at quadrant 4, not quadrant 3.
Okay, that's interesting. Okay, now let's first look. Okay, first things first, we need to look at where 270 minus theta lies. In which quadrant is 270 minus theta? It's in quadrant 3. It is in quadrant 3, and in quadrant 3, only the tangent is positive, so the cosine is going to be negative, so it's going to be negative. But because we're dealing with 270, the co rule applies, and therefore you are dealing with the cosine. So you remove the co, and you're going to be left with the sine. You're removing the co, you're going to be left with the sine. So it's going to be negative, but it's going to change to the sine of theta. Anyone? Number two, the tangent of 360 degrees minus theta. The tangent of 360 degrees minus theta. What is the answer? What is the answer? Anyone?
Negative tan theta.
Okay, well done, because you're dealing with 360 minus. So dealing with 360 minus is in the fourth quadrant where the cosine is positive, and therefore, obviously now 360 minus, only cosine is positive, the tangent is going to be negative. And therefore, just copy tan and theta, and you leave out the 360. Right, if you're dealing with 90 degrees plus theta cosine, what's the answer? Cosine of 90 degrees plus theta, what is the answer? Okay, anyone? Right, this is being recorded, so guys, you're gonna play this video. You can watch and watch and watch 100 times. So don't stress if you cannot copy everything now. Okay, we're dealing with 90 degrees plus theta. Okay, 90 degrees plus theta, in which quadrant is it? Okay, 90 degrees plus theta is in the second quadrant. It's in quadrant 2. The only sign is positive, and therefore cosine is going to be negative. But we need to remember that at 90 degrees, the function must change to the corresponding co-function. You have cosine, and you must remove the co, be left with sine, so that's going to be sine theta. So 180 degrees plus theta, in which quadrant is it? 180 degrees plus theta, in which quadrant is it? It's in the third quadrant, where the tangent is the only one that's positive, and therefore the sine is negative. Okay, what's the answer to number 4, anyone?
Negative sine theta.
Negative sine theta. Negative sine theta. Okay, let's continue and look at other things, because we can't just be bored like this. We can't just be bored like this. So let us practice and do some simplifications. Let's do a couple of proofs. Prove that. Prove. Let's look at some proofs. Let's prove something. Prove the following. Number 1. Sine x plus cosine x is equal to 1 plus 2 sine x cosine x. Then we're going to do number 2 as well. Sine to the 4th power of theta minus cosine to the 4th power of theta is 1 minus 2 cosine squared of theta. 2 cosine squared of theta. Let's look at the solution to this. Okay, let's look at this very carefully. Okay, how do we prove the first one, guys? Tando? What do we do? What can we do to prove the first one? How do we prove the first one? Zenulo? Okay, now we have the signs, the sign of x. So, parallel, please think about this. Right, so if this is 1 plus 2 sine x, cosine x, how do we prove this? How? Where do we start? Anyone? Yolande, you know this. Okay, take the left-hand side. Or you can take the right, but you start with one side and produce the other side. So personally, I'm just choosing the left. All squared. The left-hand side equals. Okay, to square these now, you first square the sine and become sine squared. Then you have sine x times cosine x times 2, which is 2 sine x. Cosine x plus you square the sine, the cosine. The left-hand side. So now you can group like terms together, obtaining sine squared plus cosine squared x plus 2 sine x cosine x. Okay, so we have the left-hand side. What is sine squared x plus cosine squared x? It is 1 plus 2 sine x cosine x. And therefore, this is equal to the right-hand side. This is exactly the right-hand side. So now the left is equal to the right-hand side, and we have proven this identity. Now let us look at more proofs, but more proofs. We need to prove number 2. Sine to the 4th power of theta minus cosine to the 4th power of theta is equal to 1 minus cosine squared of theta. How do we prove this? Anyone? Right, I hope you're not sleeping. Number 2, you have this sine to the 4th power minus cosine to the fourth power is 1 minus 2 cosine squared. Okay, to prove this, you take one side and produce the other. The easiest is to take the most complicated side with lot of higher powers and more terms. And in this case, you take sine to the fourth power, cosine to the fourth power. So which means the left-hand side. Okay, this is like it's biquadratic. So which means that it's like a difference of two squares, but you can write it like so. You can write it like so. Okay, there's a theta there. Okay. So this is theta. So there's 2, 2, 2, 2, which is the 4. All right, difference of two squares is that if you have a squared minus b squared, it's a minus b into a plus b. Sine squared theta, cosine squared theta. Sine squared theta plus cosine squared theta. Like this. Okay, let's continue. So you have the left-hand side. What is sine squared theta plus cosine squared theta? This is 1. Right, but we know that sine squared can be written as 1 minus cosine squared theta minus cosine squared theta. So that sine squared theta plus cosine squared theta is 1. And therefore the left-hand side is 1 minus 2 cosine squared theta, which is the right-hand side. Right, so we have proven this identity in the yellow color. We've proven this identity in the yellow. Right, let's look at more problems for us to try. Let's look at this one. Simplify. Number 1. Ten squared beta. 10 squared beta plus 1. Need to simplify this, and then number 2. 1 minus cosine x into 1 plus cosine x square root of this if 0 degrees is less than x less than 90 degrees. Okay, let's look at this. How do we prove the first one? Number 1, how do we simplify the first one? Anyone? 10 squared beta over 10 squared beta plus 1. How do we simplify this? How? Where do we start? What do we do first? What is the first step? 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 Are you sleeping? Number 1, guys, what is the first step of simplifying this? What is the first step of simplifying this? Is it too hard? Tando, what do you think? I know that Tando is still learning these things. Tando, I know that Tando is saying, but I'm still very young. What do we do here, Tando? Okay, there are a couple of ways to deal with this, but one of the ways is to write these as everything in terms of sine and cosine. Sine squared beta over cosine squared beta. Sine squared beta over cosine squared beta. And once you get to this, you have the LCD problem. Here, the cosine squared appears in both the numerator and the denominator. So cosine squared cancels, giving you sine squared. Okay, cosine squared now, if you multiply these, cosine squared cancels out, leaving us with sine squared. Plus, then we have cosine squared plus 1, which by 1, which is cosine squared. Everyone knows what sine squared plus cosine squared is. Even Tando knows. What is sine squared plus cosine squared, Tando? It's a big one. And therefore, this is sine squared beta. And this is the answer. So now, 10 squared beta over 10 squared beta plus 1 is sine squared beta. Let us look at more proofs. This one. The examiner claims that the sine of theta over cosine theta plus cosine theta over sine theta, 1 divided by the sine of theta times cosine theta. Plus cosine theta. And then here you have cosine theta. This is 1 over cosine theta plus 2 sine theta. And then here it is 2 sine theta. How do we prove number 2? We look at the solutions to this. We look at the solutions to this. We get the solutions to this. Right, number 2, Tando, what do we do? Anyone? Okay, number 2. Might have lost Tando. That's okay. Maybe there's something to do. So here, that's number 1. 2, number 2. Sine theta over cosine theta plus cosine theta over sine theta 1 over sine theta plus cosine theta. Okay, we need to prove this, and we present a solution to this. Present a solution to this. Which is sine theta over cosine theta. Cosine theta over sine theta. Here you take the LCD, lowest common denominator, you multiply the two. Cosine theta times sine theta. So you divide here, cosine theta times sine theta, divide by cosine theta, so you have sine theta by sine theta. You get sine squared theta. Divide this one by sine theta, so that you have cosine theta times cosine theta, which is cosine squared. Sine squared plus cosine squared is 1 over. Here you can start by writing the sine theta, cosine theta. And this is equal to the right-hand side. So we just took the LCD here, and hence, if you have sine theta over cosine theta plus cosine theta over sine theta, the result is 1 over sine theta cosine theta. Right. Okay, this one we need to simplify. I have parallel on the line. 1 minus cosine theta. Okay, called it x before. Just maintain the x variable. And then into 1 plus cosine x. Okay, this if less than x, less than 90 degrees. Okay. So now you let. Okay, here, to simplify this, when I show the simplification, the question is in white and the solution is going to be in yellow. Right, to simplify this, you have the square root of everything here. So you're just going to have the square root. So you expand 1 times 1. So you multiply this with that. Multiply this with that. You multiply this with that, and you multiply this with that. 1 times 1 is 1 plus 1 times cosine x is cosine x minus cosine x times 1 is minus cosine x. Minus cosine x times cosine x is minus cosine squared. Cosine x minus cosine x is 0. 1 minus cosine squared x. So that 1 minus cosine squared is sine squared. Okay, when the angle theta lies between 0 and 90 degrees, you have 180 degrees here, 270 and 360. Okay, between 0 and 90 is in the first quadrant where all are positive. All are positive, so this is going to be positive. In principle, it is the absolute value of the square. The square root of the square is the absolute value. Is the absolute value of sine x, or the modulus of sine x. And then if it is the modulus of sine x, but it then becomes positive because of the restriction. Sort of the domain restriction, because now we're in the first quadrant, so it becomes sine x because the angle x you have this. Next. Next. We need to simplify this one. Sine theta plus cosine theta divided by cosine theta 1 over cosine theta plus 2 sine theta. How do you prove this one here? Anyone, please? What do we do? Okay, obviously this one here, we might just take one of the sides, etc., and produce. Take the most complicated side. We in this case, it is the left-hand side. So, yeah, okay. Okay, you need to prove here. The instruction is you need to prove. Right, so you need to prove this. So you're going to take the left and produce the right, or anything of that sort. So you have the left-hand side, which is the sine of theta, cosine of theta squared divided by cosine theta. So if you square this, it's sine squared 2 sine cosine squared divided by cosine theta. Sine squared plus cosine squared is 1 plus 2 sine theta cosine theta. You divide by cosine, you divide by cosine. Cosine cancels, and you have 1 over cosine theta, 2 sine theta. Right-hand side. So we have proven this here, as we have done. Okay, pay particular attention to the steps, and as we do the next example, even if you can't copy everything, yeah, this video is being recorded. There's a question you need to prove. You need to prove that if you have 1 minus sine theta, 1 divided by 1 plus sine theta, divided by cosine squared theta. How do you prove this, anyone? What is the first step? Okay, to prove, you take a side. Take the left. So you have 1 minus sine theta. So divide this one by 1 minus sine, and you get 1 plus sine, and multiply by 1, which is 1 plus sine theta. You drop the plus. Then you have this divided by 1 plus sine. You have 1 minus sine, multiplied by 1, which is 1 minus sine. Sine theta minus sine theta. 0. 1 times 1 denominator is 1 minus. This is like a difference of 2 squares. It's 1 times 1, then you have the sine by sine, and is sine squared theta. If you remember that sine squared theta plus cosine squared theta is 1, you transpose, you move the sine to the other side, so that you're left with cosine squared theta, which is 1 minus sine squared. 1 minus sine squared is cosine squared. Right, 2 over cosine squared is our beautiful right-hand side, so we have been able to prove this result as well. Now, I want us to spend a bit of time on reduction formulae, and we shall call it a very good day. As part of our practice strategy and as part of our math study strategy, we need to practice more mathematics and record our videos for you to watch all the time. Right, so we're gonna actually we continue. So we continue.
Yes, sir, I'm still here.
Oh, Senula is still here. Good. Excited, Senula. Let's look at reduction formulae. I'm looking at the reduction formulae for Pegelelo because Pegelelo is still learning these things. Yeah, I'm just learning them for the first time. Reduction formulae. Okay, now let's draw the cast. Just look at the cast rule. Right, so look at the cast rule. I want us to just discuss some reduction formulae and call it a very good day. Because I want Pegelelo to be more familiar with this, the cast rule. Right. Okay, the cast rule begins with a diagram like this. Zero, 90, 180, 270, 360. Right, so in view of the cast diagram, we have here these 90 degrees. So this one is the first quadrant, the second quadrant, the third, and then the fourth quadrant. Okay, so let's put a little bit more information here. So this one will be 90 degrees plus theta, 180 degrees minus theta. Here, if you're at 180, you want to go to 270, so it becomes 180 degrees plus theta, but also if you are at 270, you want to go back to 180, it's 270 minus theta. Okay, you are here and you are at 360 degrees. You can have 360 degrees minus theta, but you can also have 270 degrees plus theta. So here, if you're here, you can have 90 degrees minus theta, which means you can also have 360 degrees plus theta. So we continue. So now, number one, if you have the sine of 270 degrees minus theta, what is the answer? The tan of 360 degrees minus theta, what is the answer? The tan of 180 degrees minus theta, what is the answer? The sine of 180 degrees plus theta, what is the answer? The cosine of 270 degrees minus theta, what is the answer? Okay, now let's complete this here. We start as follows. Now 270 minus theta, 270 minus theta is in the third quadrant. In the third quadrant, we have 270 minus theta, but the only function that is positive in the third quadrant is the tangent function. Okay, if the tangent is the only positive function, so we can see therefore that the sine itself is going to be negative in the third quadrant. But at 270 degrees, something applies, and that is called the Coco rule. So that sine has no co, and you put on a co, and it becomes cosine theta. Becomes cosine theta. Okay, let's look at the next one. The tangent of 360 degrees minus theta. What you got? The tangent of 360 degrees minus theta. Anyone? What's the answer? Number two. The tangent
Negative tan theta.
is negative 10 theta. So, okay, is very correct. So if you look at 360 degrees minus theta, you're dealing with the fourth quadrant. So 360 degrees minus theta, you're dealing with the fourth quadrant where the cosine is the only one that is positive there. And therefore the tangent is going to be negative. And because it's 360, there's no cofunction change. And you only copy the tangent and the theta. So now if you have 180 degrees minus theta, 180 degrees minus theta, in which quadrant is it? 180 degrees minus theta, in which quadrant is it? So 180 degrees minus theta is in the second quadrant where the sine is the only one that is positive, and therefore the tangent is going to be negative. And then you copy tangent and theta, like so. Okay, if you're dealing with the sine of 180 degrees plus theta, what answer do we get? What answer do we get? The sine
Negative sine theta.
Yes. Okay, good. So now if you're dealing with 180 degrees plus theta, 180 degrees plus theta, 180 plus theta is in the third quadrant, 180 degrees plus theta is in the third quadrant, and only the 10 is positive, and therefore the sine here is going to be negative, and you only copy the sine and the theta. Perhelelo, you're still learning these. What do you think the answer to number 5 is? I know. Okay. Perhelelo is still
I think they are gone, sir.
I think they're gone, eh?
Yeah, they are gone.
Yeah, okay. Perhelelo is still here.
Sir?
Yes, you're still here, Perhelelo, right?
So the Coco rule only applies when you're on the third quadrant.
Yeah, the Coco rule applies at 90 and 270.
Oh, okay.
Applies at 90. It applies only when you have 90 here, 90 minus, 90 plus, or 270 minus, 270 plus. That is when the Coco rule applies. So in
So
each
the Coco rule is the same
yes.
as 90, sir.
Please
So the
come
Coco rule is the same as 90.
Yes, the Coco rule is the same as 90 or 270. Okay, 90, yeah, 90 or 270. But there are more
Okay,
angles. There are more angles that are like 90 or 270, but 90 or 270 are the most basic. But the examiners normally can go higher and higher.
over revolution. Yes, I know, sir. over the
Yes,
revolution.
over
But
revolutions, etc. Yeah. Okay, I'm happy that you're able to realize that because the angles that are more than 360 and you can have 450 and so on. Okay, we're going to look at those. But yeah, I'm looking at like 270 degrees minus theta. In which quadrant is it? What do you think, Perelelo? 270 degrees minus theta, in which quadrant is it?
The third.
It is in the third quadrant. In the third quadrant, the only function that is positive is which one? In the third.
10.
It is the 10. It is the tangent function so that the cosine is negative. Cosine is negative. And then now there is a co-function change at 90 and 270. The co-co rule applies at 90 and 270. So it's going to apply here because it's 270 and it's going to change cosine. Cosine has a co. You need to remove the co by the co-co rule. The co-co rule says if you have a co, remove the co. So if you have cosine and you remove the co, you're going to be left with what?
Sine.
It's going to be
And
sine
it
theta. It's going to be sine theta. Okay, we're just practicing because I'm trying to get Pechalelo on board because Pechalelo is still learning these things, but like learning them for the first time ever. So I'm trying to make sure that I bring you on board, Pechalelo. Let's practice once more, and then we're going to go to other things. But I want us to change these ones, these problems, and just change the functions and put new functions. And then see if Pechalelo can be able to, with Tenulo, can be able to give us some correct answers. And then we're going to jump to other things, okay? Now, let's just remove all these. And we're going to put other functions here. Let's put other functions like the following. So if you have the sign here, and if you put the sign everywhere, okay, if you put the sign, okay, not good to put the sign everywhere. Somewhere you need to put something else. Okay, let's put plus here. Okay, good. Let's look. Something's gonna be different. Okay, now Pechalelo, I want to deal with you a little bit more. You'll forgive me because I know that you are learning this for the first time, but I know that Senilo has a lot of experience when it comes to dealing with these things. So I'm trying to give Pechalelo like a chance to lift off and to learn and sort of like understand this. Right, Pechalelo, in which quadrant do you think is 270 degrees plus theta? In which quadrant is 270 degrees plus theta in this cast diagram?
the fourth quadrant.
Good. Now, 270 degrees plus theta is in the fourth quadrant. 270 degrees plus theta is in the fourth quadrant. What function is positive in the fourth quadrant?
Cos theta.
This cosine theta, so that the sine is negative. But now, the co-co rule applies because we have 270. If you have 270 or 90, okay, so what is the co-function of sine? It changes, sine changes to what according to the co-co rule? Because now the co-co rule will tell you that sine has no co. If there's no co, you put on the co and sine becomes what?
Cos.
cosine.
It becomes cosine. It becomes cosine. It becomes cosine. Sine becomes cosine because the co-co rule says if there's no co, put on the co and becomes cosine, and we normally write only cos theta, like this. Right, next question. Okay, I'm trying to get Pechalelo to master these with these last few questions, and then we're gonna like do a lot of exam questions. Right, 360 degrees minus theta. In which quadrant is 360 degrees minus theta? Pechalelo?
The fourth.
It is in the fourth quadrant. Well done. And the fourth quadrant is only cosine that is positive, and therefore this sign is going to be negative. Okay? And therefore, what do we write? What else do we write here to write the full answer, complete answer? What do we write, Pechalelo?
Sine theta.
You write sine theta. Well done. Sine theta. And then now, okay, I know that it's becoming easy and they're very boring and it's easy, but yeah, we're gonna be doing like lots of trig. Right now, 180 degrees minus theta. In which quadrant is 180 degrees minus theta? Pekhalelo, what do you think?
The second quadrant.
180 degrees minus theta is in the second quadrant. Well done. Okay, second quadrant, and the only function positive there is the sine theta. So, and the examiner is having sine here, and therefore the answer is going to be positive. And therefore, what else do we write?
Sine theta.
Sine theta. Well done. Okay, you see, becoming a superstar, getting 100% in the math exam. Okay, now let's look at this one now. In which quadrant is 180 degrees plus theta? What do you think, Pekhalelo? 180 degrees plus theta, in which quadrant is it?
The third quadrant.
Well done. Well done. It's in the third quadrant, and the only function positive is the tangent of theta, and therefore the sine is going to be a big negative. And what else do we write?
Sin theta.
The sine theta. Okay, number 5 is a little bit tricky. It has a 270. It has Coco rule in it. Okay. What is going to be the answer to number 5? It's tricky. It has some Coco in it. It has Coco rule in it because it has 270. So what answer are we going to have to number 5? Okay, first questions first is to say, the first question is to say, in which quadrant is 270 degrees minus theta? In which quadrant is 270 degrees minus theta, Pekhalelo?
The third quadrant.
Well done, the third quadrant. You see, I'm trying to get Pekhalelo involved, and I can see that you've already mastered this trick, and now the most interesting things will be the exams, and the exams are coming thick and fast. The past exam questions are coming thick and fast. So 270 degrees minus theta is in the third quadrant, and the tangent is the one that is sitting there in the third quadrant, and is the only one that is positive, and therefore the sign is going to be a negative. And then what else do we write, Pekhalelo?
Is it gonna be the cosine?
Cosine theta, because of the co-function change at 270, because of the Coco rule. Sine has no co. The Coco rule says if there's no co and there is 270, put on the co, and it becomes cosine with the negative. Okay. Right. Let's get cracking with more exams. Let's get more exam questions that are very interesting. Okay, let's get more exam questions, and we're gonna have lots of them. Let's get cracking. I have lots of exam questions. Let's get cracking with these ones and get the mind learning and get more excited and master the exam questions and now get 100 full marks in the exam. Full marks in the exam. So we are preparing for the exam. Want to make sure that by the time the exam comes, we leave no opportunity to chance, and we scoop all the marks. We scoop full marks, 100% mathematics exam. So we are really good and getting ourselves very prepared. So let us look at these particular questions here. Here's a question that says simplify. Right, this is a big question, so it needs a lot of energy. So please make sure that you fuel yourself. Make sure that you fuel yourself. You need to simplify these when you have the sine of 90 degrees plus x times cosine squared of 90 degrees minus x. And you divide by the following. You divide by the following. Cosine of 180 degrees minus x. The sine of 180 degrees minus x. The tangent of 180 degrees plus x. The cosine of minus x plus 360 degrees. Right, let us simplify this, and the answer is going to be in yellow. In which quadrant is 90 plus x? 90 plus is in the 90 plus theta is in the second quadrant, and only the sign is positive in the second quadrant. So 90 plus is in the second quadrant, only the sign is positive, so the answer is going to be positive. But what are we going to write? What is it going to be? Because now the Coco rule applies here, where you have the sign of 90 plus. What is the answer to this? Just the sign of 90 plus x. What's the answer? So in the end, we can see that 90 plus is actually in the 90 plus x is in the second quadrant, where the sign is the only one positive. So the answer is going to be positive. But the Coco rule applies, meaning it's going to be positive, but it's going to change to the cosine of x. Right. 90 degrees minus x in each quadrant is 90 degrees minus x. 90 degrees minus theta is in the first quadrant, where everything is positive. So the answer is going to be positive, but there is but it's going to be positive, but there is the Coco rule applies because of the 90 degrees. What answer is it going to become there? Cosine squared, 90 degrees minus x. What does it become in the first quadrant? 9 degrees minus is in the first quadrant. So because of the Coco rule says that if there's 90 degrees, remove the co. In the word cosine, if you remove the co, you're left with sine, and that becomes the sine squared of x. The denominator, 180 degrees minus x in each quadrant, is it? 180 degrees minus theta is in the second quadrant, and the sign is the only one positive there in the second quadrant, and therefore the cosine there is going to be negative in the second quadrant. It's going to be negative cosine x. Put in some parentheses like this. 180 degrees minus x, we've already seen, is in the second quadrant, and in the second quadrant the sign is the only one positive, so this is going to be the sign of x. 180 degrees plus x. 180 degrees plus x. 180 degrees plus theta is in the third quadrant, and in the third quadrant, the tangent is the only one that is positive. Only one that is positive, so let's check what function we have. Right, so the tangent is the only one that's positive, and we have the tangent, so it's going to be the tangent of x. 360 minus x. You see the fourth quadrant? In the fourth quadrant, what do we have? We have that the fourth quadrant is only the cosine. 360 minus theta is in the fourth quadrant. In the fourth quadrant, only the cosine is positive, according to the cast rule. So in other words, this is going to be positive cosine x. Okay. What is all these? This one cancels this. Sine x cancels one of the signs in the numerator, leaving sine x in the numerator, and the denominator is going to have the tangent of x and cosine, and the tangent of x is sine x, cosine x, cosine x. Cosine cancels cosine, and we're left with the sine cancels the sine, and the result is a 1 that is negative, because there's going to be a negative that is in the denominator here. It's negative in the denominator. Cosine cancels cosine, but there's a negative, so yeah, there's going to be a -1, and that is the answer. So think about this and make sure you sort of understand this, because another question is loading, but very thick and fast. Very thick and fast. But I want us to remember our old friends, the special angles in trigonometry, because these are very important. So now let's recall the special angles. So here's a question that says simplify. (100°). Tan squared of 2 to 5. Tan 30. Cosine 370. The sine of 120. Right, we need to simplify these, but on the side, I want to mention the special angles. What are they? 30, 45 degrees, and 60 degrees. So 30 degrees, 60 degrees. Square root of 2, 1. But there's another 45 degrees. Which is a square root of 2, 1, 1. All right. I'm going to write the answer in white. Okay. Right. The question is in yellow. All right. So if you have this, what do we do next? Okay. We're going to play around with this and get the answer once, so we're good. Okay. What do we do here to simplify these? 100 degrees. What do we do with these? So, well, there are many ways to do this. One of the ways we can say it is the 100 can be seen as 90 degrees plus 10. 9 degrees plus 10 degrees is going to give us 100 degrees. The tangent of 180 degrees, tangent squared of 180 degrees plus 45. Okay, so we also have 1030. Can leave that one for now. It's nice and acute. We just need the special angles, so just reducing the larger angles. like 370, you can reduce it because we can write 360 plus 10. 360 degrees plus 10 is 370. Right, 120 can be reduced in many ways, but I advise the students to use 180 degrees. 180 degrees minus 60 degrees. So what we get here? So 90 degrees plus theta is in which quadrant? We saw that it is actually in the second quadrant, and the second quadrant is only the sign that is positive, but there's a co-function change at 90 degrees by the Coco rule. Right, so we're going to have a positive answer, but there's no co. The Coco rule says put on a co, it becomes cosine, and we only write cos of 10 degrees. Positive because we are 90 plus in the second quadrant, the sign is positive there. 180 degrees plus theta is, or 180 degrees plus 45, it's going to be actually in the third quadrant, and the tangent is the only one that's positive, so this is going to be positive, giving us the tangent squared of 45 degrees divided by, in the denominator, you have the tangent of 30. 360 plus is in the first quadrant where all functions are positive, and therefore this one is going to be positive cosine 10. Right, 360 plus is in the first quadrant, but in the first quadrant, all functions are positive, so it's just going to be positive cosine 10. 180 degrees minus is in the second quadrant, and the sign is positive there. Only one that is positive in the second quadrant, so the result is going to be positive, the sign of 60 degrees. Right, so what do we have? We have cosine 10 multiplied by 10 squared 45. $10.30 cosine 10 sine 60 cosine 10 sine 60. And our old friend of these special angles, $60 degrees 30. At 45, the 45-degree special triangle. Okay, this is 90 degrees here. Did I include the 90 degrees there? Okay, yeah. 9 degrees here, 9 degrees there. So, but we also have 9 degrees, 9 degrees, 45 degrees, 45 degrees. Square root of 2, 1, 1. Okay, now the 45-degree triangle is there. Okay, let's get cracking. Cosine 10 cancels like cosine 10. The tangent of 45 is use the SOHCAHTOA. Right, using the SOHCAHTOA, the tangent is opposite of adjacent, but look at the 45-degree triangle. Right, opposite 45, opposite over adjacent, which means it is 1 over 1. So it's like 1 over 1 squared, all squared because of the square of the 10. The tangent of 30 degrees, we're looking at the tangent of 30 degrees, and the tangent of 30 degrees is the same as what? Right, 10, wherever you see the tangent, then you're dealing with the opposite over the adjacent. 30 degrees, opposite is 1, adjacent is the square root of 3. Opposite 30 is 1, adjacent square root of 3 is 1 out of the square root of 3. Sine 60. This is sine 60. Opposite of hypotenuse. Opposite of hypotenuse, sine 60. Opposite of hypotenuse, square root of 3 over 2. Okay. So which means 1 divided by 1 out of 2. So 1 divided by 1/2 is 2. 1 divided by 1/2 is 2. And that is the answer to this problem here. What was the problem? Well, this was the question in yellow. We had to simplify that expression. And we wrote a couple of steps that seek to help us simplify that expression. Many times we encounter a lot of problems like this, and we need to be better prepared to play around and solve more problems. Let's practice more with these problems. More trigonometry. At this point, we are interested in saying if the sine of 32 degrees equals k, determine the following. Determine the following in terms of k. Determine the following in terms of k. In terms of k. Right, number 1, cosine 58 degrees. Number 2, the sine of 212 degrees. Number 3, the tangent of 32 degrees. Okay, let's look at this. What do we do here? So I'm gonna consider the diagram here. 32 degrees is an angle that is somewhere here. (32 degrees). So at this point, this is soccer tower, and therefore the side of 32 is like opposite of hypotenuse. Opposite of hypotenuse. Opposite of hypotenuse. And therefore, this is like R, this is like Y. You're interested in this one, which is like X. So how do we get the X here? Right, to get the X there, let us use a result. Pythagoras theorem. Pythagorean relation. X squared plus Y squared is R squared. So you come here. 1, the Y is K squared, X squared. X is 1 minus K squared. 1 minus K squared. Okay, obviously, ordinarily here, you're going to have a plus or minus. Okay, I must indicate that when you're solving this equation, when X squared plus K squared is equal to 1, and you have to find the X. So you're going to have that X is plus or minus, but because you are in the first quadrant here and X is positive, so you're going to take only the positive. Okay, if this one is 32 degrees, this one is 90 degrees in the triangle, we are putting the 32 degrees that appears here. 32 degrees appears there. Now, this angle here must be 58 degrees because this one is 58 degrees. It's exactly 58 degrees because if you add 50 plus 30 is 80 and then 90. Okay, the angles here must add up to 180 degrees. Supplementary angles in a triangle. Okay, right. So with that said, we are in a position to just complete this with ease. Like cosine 58. Okay, there's 58 here already. So you can use SOHCAHTOA. You can use SOHCAHTOA so that when you have the cosine, then it's adjacent of hypotenuse. Dealing with 58 degrees, adjacent of hypotenuse. Cosine is adjacent of hypotenuse. 58. Adjacent is k. Hypotenuse is 1. K over 1. And the answer is exactly k. Right, so that is the answer we're getting. But there are many ways to do it. Another student can come and say, this is the same as cosine 58 is the same as 90 degrees minus 32. Let's check this one. 90 minus 30 is 60, and then yeah. So you can say 58 is 90 minus 32. In which quadrant is 90 minus is in the first quadrant where everything is positive, but it's a cofunction change at 90 degrees by the Coco rule. Positive everything in the first quadrant, 90 minus, but there's a Coco rule, which means you have the sine of 32 degrees and the sine of 32 is k. So in other words, I mean, there are many ways to kill a cat here. The cosine 58 is k. There are just too many ways to do the question. Okay, let's look at the sine of 212. The sine of 212 can be seen as 180 degrees plus 32 degrees. 180 degrees plus 32 degrees. In each quadrant is 180 plus. The third, where the sign is negative, but the 10 is positive in the third quadrant, so the sign becomes negative, the sign of 32. Sine 32 is k, and this becomes minus k. Okay, to learn from these, you need to repeat these questions. You need to watch the video, make sure you understand, cover the solution, and see if you can solve the question on your own. Okay, that is how you learn mathematics. You repeat and repeat and repeat and repeat the problems, and make sure you can do it, you can do it, you can do it again and again and again and again. Okay, let's look at the tangent of 32. 32 already appears here. Okay, 32 already appears here in the triangle, but we're using SOHCAHTOA, so TOA at opposite of adjacent. Tangent is opposite of adjacent. 32, opposite 32 is k, adjacent is the square root, so that becomes k over the square root. 1 minus k squared. Okay, this is the answer. I feel like we're trying to do something this afternoon. And now we're taking a short break. And now taking a short break, we can be right back again. Maybe today we're enough. Maybe today I can give you a little bit of time to relax. And then tomorrow, okay, I can meet you again tomorrow, but yeah, it's not exam time that we can use a lot of the nights. You have other subjects to focus on. Some of you have history, you have geography, so you have other things to focus on. So let me not keep you awake till late. You are going to school, you're gonna struggle to wake up in the morning. Okay, right. Okay. So I'm gonna send you messages on WhatsApp, but yeah, we can meet at 7 p.m. We can meet at 7. 7 p.m. if you guys are okay with that, or 8 p.m. The best is 8 p.m. Yeah, but I think that most of you can manage 8 p.m. well, because by 7 you are still in the street. You are still buying bread from the shop for the next day. So I think that 8 p.m. is okay. So if we meet tomorrow at 8 p.m., we're gonna like do more questions on what is currently happening in school now. I'm gonna bring more topics than this, and we're gonna practice more, but also more past exams, please, are gonna be featuring our discussion tomorrow. So tomorrow at 8 p.m., we're gonna be cracking more problems. So yeah, you can join me tomorrow. 8 p.m. is fair enough. 7 is still a bit early, I think. Some of you are still cooking, so by 8 you're settled, you have taken your dinner. So right, I think this is good enough. I feel like doing more, but I know very well that it's not going to be very helpful if I break your back. It's not the end of time. It's not the end of time. It's still have lots and lots of time. But I must give you a small exercise sort of practice. It's not fair to just teach and teach and teach and teach and not give anything extra, so that during your own leisure you can exercise your muscles, see if you fit enough. So I'm gonna be just putting a problem here for you to try. So stay put and stay tuned. Stay put and stay tuned. I'm loading one problem. Right. Here's the question. So what am I doing now? What I'm giving here is a home activity for you. It's a home activity. If the tangent of 27 degrees equals P, express each of the following in terms of P. (27 degrees, number 2). Number 3. Okay, 63. So this one here is sine of 63. Number 4, the tangent of 153. Number 5, the tangent of minus 27 degrees. Number 6, cosine squared of 387. So this is the answer, or this is rather a home activity. So please consider this home activity and make sure you sort of understand what's happening here, because it's so good for you to practice. and you get these problems during your own leisure. You practice this, and these problems are so good. This particular home activity is what you meet at grade 11, what you meet at matric. So yeah, it's good, both grade 11 and matric. And you use exactly the same approach like we did here. 32 degrees is in the first quadrant. That's why this was done here. Obviously, we always bear in mind this is 0 degrees. This one is 90 degrees. This is 180 degrees. This is 270 degrees. This is 360 degrees. So even here, you would basically obviously do the same. 27 degrees is like in the first quadrant, so you do the same. Okay, right. I must thank you guys for joining us. Tomorrow at 8 p.m., we're gonna meet again. I'm gonna send you a timetable on the thing on WhatsApp. So the timetable we're gonna be following. We need to gear up our commitment towards math and science mastery. Math and science mastery. But I think for today is pretty enough. And I'm gonna send you a timetable. And here's the home activity for you to try to during your own leisure. Yeah, I'm gonna give corrections to these, can give corrections to these, but yeah. Okay, thanks a lot, everybody. See you tomorrow at 8 p.m. Okay, the classes at 8 p.m. and the class I suggest, they are just there to keep you busy. Our main session is Saturday 4 p.m. But during the week, I throw in sometimes. If you are busy at those times, you are welcome to stay away. If you are doing athletics, so you are in the field of play, you are practicing soccer, etc., you can stay away. But if you're free at the extra times that I'm going to throw in during the week, you can just join us for us to practice more. But our main meeting time is Saturday 4 p.m. But yeah, thanks everybody and goodbye to you. Goodbye, guys. Bye.